And we are T-minus 19 seconds and counting. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Lift off.
Beginning to pitch over.
Stage 1 propulsion nominal.
Lab Launch Complex 1 and is on its way to space carrying the MAT satellite. Our rocket recovery attempt is also now officially underway. Coming up on supersonic speeds, Electron will be travelling faster than the speed of sound as it approaches its first mission milestone, maximum aerodynamic pressure. Electron's Rutherford engines will throttle down slightly to pass this pressure point, and once cleared, we should hear the call from mission control that the rocket has passed max Q.
Vehicle is supersonic. Approaching max Q. And vehicle has cleared max Q.
Stage 1
There we go.
propulsion
As expected,
holding
Electron
nominal.
has cleared that first milestone and is continuing nominally. Electron's Rutherford engines will now throttle back up as the mission continues on, and all looks nominal for propulsion there, with that beautiful view of LC1 below. In about a minute, we will reach the point in the launch when
Stage
Electron
1 guidance is
separates
nominal.
itself. Known as stage separation, the Rutherford engines on the first stage will shut down for the rocket to safely separate before the engine on the second stage can fire up and carry on with the mission. The calls for these events will proceed as MECO, or main engine cutoff, stage separation, and then second stage engine start. And here is when our recovery team
Stage 1
begin
propulsion
their
nominal.
countdown to
Stand by
the
for
helicopter
MECO in
catch
roughly
as
30
the
seconds.
first stage will begin its journey back to Earth. Standing by now, though, for those calls.
15 seconds to staging.
Entered burnout detect mode.
MECO confirm.
Stage separation successful.
Stage 2 ignition.
And as you can see, we have had a successful MECO and stage separation, followed by the engine on
Stage two
Electron's
propulsion
second
nominal.
stage igniting successfully. You can see that by the red hot glow of the Rutherford nozzle on your screen there. For recovery, the first stage is now beginning its journey back home.
Discharge
The
nominal.
trajectories for both stages are looking good so far. The next mission event will be fairing separation on the second stage, coming up in just a few moments.
Fairing jettison succeeded.
In fact, actually, there it goes. Electron's fairing has been deployed, and Matt is now exposed
Stage
to
2
space
guidance
while
is
remaining
nominal.
attached to the rocket's second stage as it continues on the path to orbit. The vehicle is now traveling at a speed of more than 8,000 kilometers an hour with an altitude of 129 kilometers. Meanwhile, Electron's first stage continues its migration over the South Pacific Ocean. When it separated from the second stage, it was traveling at such high speed that its trajectory continued upward from the momentum. But in another minute or so, it is expected to reach the highest point of that arc, otherwise known as the apogee, and from there, descend toward the capture zone, where our recovery helicopter is ready and on standby to proceed. We should hear the call out from Mission Control, and we'll keep up that first stage camera view on your left for as long as we can.
Stage 2 propulsion still nominal.
The telemetry data for both stages is on your screen and coming back nice and clear, showing the progress of the first stage. We're just starting to see that arc back downward as it heads towards Earth, whereas on the right, that telemetry line is heading upward as it should as Electron's second stage continues to orbit. This camera view on Electron's first stage tells us a lot about how well the booster is faring on its way back to Earth, because with the stage hitting speeds of up to 8 times the speed of sound, we may actually see a glow at the bottom, and that would be from plasma, which forms during the descent as a condition of a very fast atmospheric re-entry.
Stage 2 guidance still nominal, 200 seconds remaining.
Electron's second stage, though, continuing to orbit with propulsion firing hot and nominal. Fairly soon, Electron, though, will need another power source for Rutherford's electric pump cycle. We use batteries for this, but like all batteries, they run out of juice after extended use. So Electron performs an action called the battery hot swap, where it swaps over to a new set mid-flight to keep the engine running for longer. Sometimes you can catch a glimpse of these battery packs falling away. So let's listen in for the call out from Mission Control and watch our screen for those battery packs.
Engine is starting to throttle down.
Hot swap successful.
Battery jettison confirmed.
There's that call from Mission Control. Battery hot swap is confirmed. The cameras are a little bit late, but we can confirm those batteries did swap over as planned.
Stage 2 propulsion
Motor
still nominal.
pressed.
HVP discharge holding nominal.
Stage 2 guidance in terminal, 25 seconds to go.
SICO, confirm.
Stage 3 separation confirmed.
Nominal transfer orbit.
There we go. That's the call for SICO or second engine cutoff, and stage separation has been confirmed. That means Mats and Electron's kick stage have commenced their first pass around Earth in its initial orbit. Around 40 minutes into this coasting phase, the kick stage's engine will light up to move it into a circular orbit position where payload deployment will be performed. We'll come back to that final mission action, but while Mats takes a cruise, we are full screen with the camera view from the helicopter as our pilots move in for the mid-air rocket catch attempt. Between the main parachute deployment and the time it would take Electron to reach the ocean, our pilots have about 10 minutes only to complete the catch. And catching a rocket with a helicopter is a tricky operation because within that time pressure, our pilots need to control the Sikorsky, balance the swing of the hook underneath while it's attached to the helicopter's line, hook it precisely to Electron's parachute line, and then secure the rocket beneath them for the journey back home. Now, right now, the mission is on track to do all of those things, but just in case, we are prepared with a nearby ship should we need to fish Electron out of the water instead today. To make sure you catch Electron gliding into view, keep your eye on the edge of the screen where we expect to see it today. Just a note on the soft water splashdown I mentioned before. If we did that today, that would not be a failure for our recovery program. In fact, we've performed several of them across our missions to date, and most recently, we were able to refire a Rutherford engine that had been returned from the ocean. Right now, though, we have an anxious wait with our fingers crossed until we might see Electron again on our screen. Our rocket spotter on board the helicopter has a few more tools to help them with this task, obviously. They've got this view and the view out the window, of course, but also those display screens that plot theirs and Electron's positions with telemetry and where they might intersect for that catch attempt. While the Sikorsky has been positioned out here over the ocean during mission operations, it's got a range of 950 kilometres. That means it can safely capture and return Electron to land following a successful catch. And now that Electron's first stage is empty of propellant, it will weigh approximately a tonne in dry weight. Our Sikorsky, though, is rated to be able to carry up to 5 times that, so we've got good margins for a catch and carry back to land. Our Rocket Lab team back here at Mission Control who are watching as anxiously as I am to see that Electron glide into view. Whether they've touched this mission themselves or have supported across some other functions through the business, everyone is just as invested in seeing Electron brought back to the factory. The recovery team themselves are stationed in various support locations. Some are in the Mission Control Centre, others are on our recovery vessel on the ocean near the capture zone, and of course we have the helicopter pilots as part of that catch attempt too. For those of you just tuning in, a quick reminder that we have had a successful first part of the mission, and the MATS satellite, as you can see on your right-hand side with that graphic, is in a transfer orbit on its way to its final destination. Hello again from Mission Control. We have just had an update from the pilots, and unfortunately it looks like we are not going to bring Electron home dry today, but we do have the backup option of an ocean splashdown. We'll bring you updates on that ocean operation in the hours to come, but for now we are going to leave you with the views of Electron's kick stage as it moves through its transfer orbit on the way to payload deployment for MATS. We'll be back for payload deployment at around T+50 minutes. See you then.